Welcome to the next lesson in this chapter as we continue our journey to a microservices architecture. As part of this lesson, we will be implementing distributed messaging using RabbitMQ. RabbitMQ is a reliable and very popular message broker, and it's also supported by mass transit. So what we're going to do is take the in-memory message bus that we were using so far to facilitate the communication between our modules and replace it with RabbitMQ. Mass Transit has a NuGet package that we can install and use it to connect to a RabbitMQ instance, and you will see how Mass Transit takes care of configuring the broker topology when we switch from an in-memory transport to a proper distributed messaging system. This also means that we will have to introduce an additional infrastructure component into our system, and this increases the overall complexity as RabbitMQ will be another service that we will have to manage, but nonetheless, we have to include this step before we can transition to microservices. So let's see how we are going to implement this. We're going to start the implementation by introducing a Docker container that's going to be running RabbitMQ. So let's go ahead and add a code snippet that's going to add the respective image as a container, and I will be using the RabbitMQ management image, and I'm giving it the name of EventlyQ and the respective name for the container. I'm also mapping some volumes for the queue data and logs and configuring two environment variables representing the default user. I'm going to set both the username and password to guest, and then I'm exposing RabbitMQ on the default port, which is 5672, and I'm also exposing the RabbitMQ management interface on this port. So this is going to take care of starting RabbitMQ when we run our application using Docker Compose. The next thing I want to do is to introduce a respective connection string for the RabbitMQ instance, and I'm going to add a connection string in the connection strings section, and I will give it the name of Q. Now I'm going to leave the default connection string empty and introduce the actual value in our app settings development JSON file, and this is going to be the value of my connection string. I'm going to specify the AMQP protocol, and then I'm going to specify the address of my RabbitMQ instance, which is going to be EventlyQ, and then the internal port of 5672. And with this setup in place, we can go ahead and replace our in-memory message bus with RabbitMQ. So let's head over to the infrastructure project, where I'm going to install a new NuGet package. I'm going to look for Mass Transit, and then let's look for RabbitMQ. And this is the NuGet package that we will need to install, and I'm going to go ahead and install the latest version. I'm also going to look for a health check NuGet package, and to be specific, I'm looking for a health check for RabbitMQ, and this is the NuGet package that I'm looking for, ASP.NET Core Health Checks RabbitMQ. So let's go ahead and install this as well, so we can integrate a health check for our RabbitMQ instance. I'm going to close all of this down, and let's introduce a new class into the event bus folder, and I'm going to call it RabbitMQ settings. This is going to contain a few values that I will use to connect to my RabbitMQ instance, and I'm going to specify the host, the username with a default value of guest, and the password with a default value of guest. I'm going to turn this into a record, and then let's move over to the infrastructure configuration class. Here, I want to configure our mass transit setup. So instead of configuring the in-memory transport, we want to switch to RabbitMQ. So I'm going to say using RabbitMQ, and then I need to configure my connection to RabbitMQ by calling the host method. I'm first going to introduce an additional argument to the add infrastructure method, and let's say right after the module configure consumers, we introduce a RabbitMQ settings argument, and let's give it the respective name. So now if I go back to my mass transit configuration, I can say host and create a new URI instance, and then I can say RabbitMQ setting and pass in the host value. And then I can also configure the username and password that we should use when connecting to this host. So I'm going to say username and then RabbitMQ settings and pass in the username value. And let's also pass in the value for the password, and we need to call the password method. And this is how I'm going to configure my connection to RabbitMQ from Mass Transit. As you can see, the changes we needed to make were very minimal. We just replaced the call to using in-memory with using RabbitMQ, and this allows us to connect to a different transport mechanism, in this case a distributed messaging system that's called RabbitMQ. I'm also going to introduce one more change here in the way we configure our module consumers. Other than the registration configurator, I will add one more argument. This is going to be a string value representing an instance ID, and this is just going to be the name of my service. So what I'm going to do is I will create this instance ID from the service name that we are passing into this method. I'm going to convert this to a lowercase invariant string, and I'm going to replace any dots in the name with a hyphen. And if you recall, the value that we were passing in for our service was Evently API, and I want to convert this into Evently API. This is going to be appended to the endpoints inside of RabbitMQ when Mass Transit configures the broker topology. Now I need to go ahead and fix my module configure consumers, and you will see why we are doing this in just a moment. Let's head over to the ticketing module, for example, and I'm going to update the configure consumers method. So let's introduce an instance ID, and what I want to do with this is say endpoint, and then on the endpoint configurator I'm going to set the instance ID value to the instance ID argument that we are passing into this method. So let me go ahead and update this for all of the configurations for our respective consumer, and once we are done with the ticketing module, I'm going to make the same update in the other modules in my system. After I have made this update in the attendance module and the events module as well, we should be able to build our system, and you will see that we are no longer getting a compiler warning in our configuration for mass transit. So let me close down the modules, and now the only thing remaining is to provide the respective value for our RabbitMQ settings. So let's go to the add infrastructure method, and I'm going to create a new instance of the RabbitMQ settings type. So let me say RabbitMQ settings, and then I'm going to pass in the respective connection string for our RabbitMQ instance, which has a name of Q. You can also configure the username and password from the application settings, but I'm going to specify the default values. And then I can pass in my RabbitMQ settings as an argument to the add infrastructure method. Moreover, we can also introduce a health check for our Redis instance because we already added the respective NuGet package, and I'm just going to pass in the respective connection string by specifying Rabbit connection string, and I can pass this value from my RabbitMQ settings instance. And now we should be able to start our application and see if our RabbitMQ integration is working. With our application running in the background, and if I open up Docker Desktop, you will be able to see our Evently Q container that's running our RabbitMQ instance. If I navigate to this address, we're going to see a login screen for the RabbitMQ management dashboard. So if I specify guest and guest for the username and password, we can log into the RabbitMQ management dashboard. And here you can see some information about the broker topology that Mass Transit is configuring. If we open up the queues and streams, we can see the queues that are configured by Mass Transit, and you can see we have a respective queue for each of our integration events. For example, this is a queue for the user registered integration event, and this is the name of our instance ID representing our application. The reason I introduced this right now is so that we are able to consume integration events when we have multiple services running connecting to the same RabbitMQ instance. These services will be consuming these same integration events, but they are going to be assigned a unique instance ID, which is going to produce a different RabbitMQ endpoint, and we will be able to consume the same integration event from different services. If I go into Postman for a moment and send a request to update the user's profile information, and I'm going to send a few requests in a row. So let's send request number 3 and then request number 4. This is going to publish some integration events. And if I go back to my RabbitMQ management dashboard, you will be able to see that we are processing messages in our RabbitMQ instance. So our connection to RabbitMQ from Mass Transit is working as expected. If I go into the Jaeger user interface, which we introduced in the previous lesson, where we implemented distributed tracing with the help of OpenTelemetry, I can look for the send operation of the user profile updated integration event. And then I can see the traces that were produced for this integration event. So let me take a look at one of these traces, and you can see how we are sending the respective integration event. We can also see that we are consuming this event in 2 different consumers in our application, and one of these consumers is going to write this value into the ticketing module inbox message. As you can guess, this is the consumer in the ticketing module, and we also have another consumer in the attendance components module for this same message, which means that now our messages are being published using a distributed messaging system, RabbitMQ, and we are also able to consume these messages and process them internally inside of our application. And with this, we can slowly wrap up this lesson about implementing distributed messaging with the help of RabbitMQ. One thing I want to note is how easy this was to implement because we were already using Mass Transit. And Mass Transit has some amazing abstractions for implementing distributed messaging. We didn't need to make any structural changes to how we were publishing or consuming messages. All we had to do was configure a different transport mechanism. In this case, we were connecting to RabbitMQ, and the one slight change I introduced was explicitly specifying the endpoint ID for our integration event consumers. As I said, this is going to allow us to properly consume integration events when we are running a microservices system. Now let's continue our journey to microservices, and in the next lesson we are going to be talking about API gateways, and we are going to introduce YARP as a reverse proxy inside of our system.